We'll just deal with that. Okay, I'm Stella. I'm a third-year PhD student at UW, and today I'll be talking about PrefPalette. It's about personalized preference modeling with latent attributes. Okay, so preference prediction has been integral to the modern post-training paradigm. Especially reward models are widely used during RLHF to align models to human preferences. However, we think preference modeling is more than just training a reward model, but rather about understanding the underlying factors that form human preferences. So I'll start with clarifying the difference between reward model training and what we mean by preference modeling with an example. So in this Reddit post from the AskDocs subreddit, a user is asking, my doctor wants to see me in person. I'm worried they will involuntarily hospitalize me. So I'll now show a few replies under this Reddit post, and I want us to think about which response would this community prefer and why. So the first response says, doctors can authorize psychiatric codes if they believe someone's at risk. Canceling won't prevent it, and talk to the doctor directly. Another one says, I suspect this is bureaucratic, not medical, blah, blah, blah. And another one is saying, I think it will be okay, don't worry too much, maybe he just needs an in-person meeting for side effects, blah, blah, blah. So at this point, which response do people think this community prefers? I'm not gonna wait for the answer. But anyways, so I'll show the ground truth first. The first response gets 587 likes, but the other two a lot less, despite being posted around the same time. So what current reward model training does is just to form preference pairs and train the reward model. So we may get decent accuracy, but there's no trivial way to kind of infer why a community would prefer like one response over another. However, if we look into the responses more carefully, through the PrefPalette's textual attributes that we proposed, the first response embodies empathy, usefulness, directness, but the third response represents supportiveness, benevolence, security. So these are the short social cultural values. So looking at these responses and many others, we can probably conclude that this community strongly prefers empathy, usefulness over pure reassurance. But another community, maybe like a mental health support group, would have completely different preference patterns. But if we train a reward model, especially if we aggregate all of these reward signals, we wouldn't be able to understand any of this. And that's why we want to, that's kind of what we want to discover with preference modeling instead of just reward model training. So why do we care about this? Because we believe that preference modeling powers AI alignment. To be specific, we define preference modeling as understanding and predicting human preferences, especially the why and how behind the decisions. So it allows us to infer human values without explicit labels, helps build better reward models that reflect human values to align our models better, and understanding the underlying structure can help generalization to other communities or even individual personalized reward models, and that enables fine-grained personalization. But what are the challenges in preference modeling? So first of all, conceptually, preference is treated as a component of LLM alignment right now. So we only care about like, how do we get a better reward model? How do we kind of improve the accuracy of the reward model? But preference understanding is currently pretty much understudied, and I personally think it's an interesting thing to just understand things. Second of all is model challenge. Human preference is mostly modeled as a black box process, and there's not much interpretability. Third of all, data challenge. Human preference is collected in aggregate, and it suffers from potential response biases. And if we want to understand the underlying factors, it's extremely hard to kind of like just ask the annotator, why do you prefer one over the other? Because sometimes we don't even know why we prefer it, but we want to computationally understand this post hoc. So which is why we proposed PrefPalette. It is a white box preference modeling technique. So we used 19 theoretically grounded textual attributes from sociolinguistics, cultural social science, psychology, whatever. We also designed the preference model architecture to match the human cognitive process. So there's this theory or like model called multi-attribute decision making, and we try to do the same with our computational models, so we can actually use the underlying factors to better predict preferences. While there is prior work that incorporates coarse preference in alignment and multi-objective optimization, we uniquely focus on theoretically grounded understanding of human preferences, but in like a computational way with big data. Okay, so just a quick list of contributions. PrefPalette enables interpretability, and that means we can understand why preferences emerge, and that allows us to audit AI decisions. It enables personalization to adapt to different contexts, move beyond one-size-fits-all solutions because of the underlying structural decomposition. And it also, like beyond all of the interpretability stuff, we also get better performance than just black box reward modeling. We have 46% improvement over GPT-4o. This is the biggest improvement, but we do improve over a lot of the strong baselines as well. Okay, so now let me get into the specifics of what we propose in this paper. We first address the conceptual challenge, which establishes preference understanding as an independent direction than just a component of LM alignment. So this is a quote from a psychology paper. It talks about how humans construct preferences. So we construct specific preferences from more basic values, and that's the underlying attributes that we care about. And identifying the factors shaping behavior is psychology's central challenge. So we basically want to take this idea and use it in our computational models. Second, to address the model challenge I was talking about, in which we have been training reward models as a black box. We just put in the chosen rejected pair, and then we get a score. It's basically a direct mapping from content to label, and we can't explain the decisions. To address this, we want to use theory-grounded attributes to guide the prediction for improved accuracy and interpretability. Okay, so now I'll walk us through how we actually do this. We start from Reddit posts. We use Reddit data for a lot of reasons that I'll explain later. But to match the standard preference learning paradigm terms, the instruction is our Reddit post, and the responses are comments, and our preference signal is the normalized number of upvotes. So we're actually predicting the collective preference pattern of each subreddit community, which we later analyzed to be extremely different across different communities. So the first step, we have attribute predictors. I'll explain how we train those in a bit, but we pass the textual content into the attribute predictors. So for example, we'll have a formality predictor, humor predictor, verbosity predictor. We extract the last layer embedding as the attribute representation. And the next step, we extract the context embedding using just the preference model. So this is the same as standard reward modeling. And what we propose that's kind of a novelty point is we compute a context-aware self-attention using both of the attribute embeddings and the content embeddings. So we basically just like, the output of this whole process is if we have 19 attributes, so it would be like a 19-dimensional vector to weigh the importance weights of each of the attributes based on the input and the community. And then we'll take the linear combination of all of the attribute representations, combine it with the content representation, and just use this as the last representation that we feed into the final preference model, or like the same thing as a reward model. But yeah, so this is the whole like pipeline in which I guess the whole decomposition into different attributes is what we take from, I guess, psychology and cognitive science literature. So for how we actually train the attribute predictors, there are a few issues, there are a few challenges that we have to deal with first. First of all, there is no existing clean labeled data for the 19 attributes that we care about. There's, for example, no data on like humor rating, or like how much does one comment embody traditionalism or something like that. And it is extremely difficult to collect this type of data. because a lot of confounding variables in natural data, and the nuanced labels will lead to extremely low agreement. And there's also a distribution skew in naturally occurring data. So for example, if we use Reddit, most of the data will be informal, but if we want to train a formality predictor, we need to somehow balance the data sets. So how we deal with this is we use a strong language model to generate counterfactual rewrites of each of the comments. So I'm gonna skip over this because this is proposed in a prior work that we presented on Tuesday. It's called Alpha, if you want to check it out. But yeah, basically we use these counterfactual rewrites to train the attribute predictors, and then we use that to extract our attribute representations. Okay, the next point is data challenge. Preference is usually collected in aggregates. We collect some huge preference learning data sets from a group of annotators, and we train language models, and then these language models interact with users who typically did not provide these preference data. And another point is that it would suffer from response bias. When the annotator is aware that their data is being collected, they might subconsciously provide some sort of other responses that is a little bit deviating from the ground truth. So our solution is to use Reddit data. Each subreddit, we treat that as a unique preference expressing entity. And the upvote patterns are completely anonymous, and that, to some extent, reduces the response bias. Okay, experimental setup. We randomly sample 45 subreddits from the highest activity and growth list of subreddits, and then we compare with these baselines on the slide. I'm not going to go into detail, but basically closed source models, models pre-trained on Reddit, and then some of our prior work models on training on coerced rewards. And we also modify PrefPalette to kind of not use the representation, but only use the final score of our attribute predictors. And the metric is just standard reward classification. Okay. So just a quick slide on results. We outperform all of the baselines. But yeah, I think, we outperform. This is not the interesting part. The next thing that I think is really interesting is that during these PrefPalette model training process, our importance weights for each of the attributes converge, and then we get some sort of community-specific value distribution. So then we can see, for each of the community, which attributes matter the most for their preference decision, and which attributes matter the least for their preference decision. So this is a summary. Eventually, we see distinguishing attributes in representative domains. For example, the Ask Historian subreddit places a high emphasis on verbosity, but subreddits such as No Stupid Questions really cares about assertiveness in their responses, and that determines whether they want to upvote this comment. Okay, so just a quick conclusion, some key takeaways from PrefPalette. We think understanding preference has impacts beyond just training a better language model, because this basically, we distill the social understanding of all of these attributes from a bigger model and train our community-specific reward models, and that instills social reasoning capabilities, personalization, online moderation, applications, etc. Another interesting thing is we use cognitively inspired modeling architecture, which mirrors how humans make decisions. I know I'm running out of time. And lastly, the PrefPalette framework provides interpretable latent value attributes as intermediate signals to understand things better. Okay, thank you. If anyone has questions.
Any questions from the audience?
Yeah, thanks for the talk. If I understood correctly, you are using a multi-attribute preference model, underline. So I'm wondering if you consider testing for preferential independence between the attributes?
Yeah, I think there definitely can be independence. All of the attributes are not orthogonal, but because we have we train the contextual weights for each attribute. So over time, it kind of balances out. I would imagine if two attributes are extremely similar, they would end up with a similar importance weight. But yeah, we also train with different random seeds, and finally like average all of them. So hopefully that reduces the noise a little bit. But I think in general it's pretty hard to get like completely orthogonal like directions.
Yes, thank you for the very useful talk. I kind of have maybe a higher level question. I mean, I really appreciated the, reaching out to other communities, because obviously this is not a kind of computer science problem per se, trying to figure out what people prefer. So when the communities kind of start meeting, however, there are different methodologies, and you did mention that you had a data problem. The data problem was that, how do you get the right labels for all these attributes? People don't agree. And then you kind of worked around it. But I want to be very direct. Could that mean that maybe the problem was not very well defined? I mean, if people do not agree on the labels, it means that these labels are not ready yet for, we don't have a good understanding of using them as a tool for advancing scientific research in that area, because people don't agree. So maybe it's not, the labels, they come from a different field, and maybe they're not at the stage where, we capture the problem.
Yeah, I think that's a really good question. But yeah, I agree. I think there's we definitely, if we want to collect human data, we should definitely chat with more people from other communities and better define the task. But another thing that I wanted to add is that all of these human decision-making process, although they rely on some underlying attributes, sometimes the decision is implicit. So it's not like humans be like, okay, this is more humorous, therefore I upvote this. So I think a lot of the times it's also implicit in a human's mind, and that also adds to the difficulty of labeling those data. But yeah, I think it would be really cool to work with other communities to actually collect this sort of labels.
Okay, in the interest